right. Hey, I think it's about time to get going. So, hey, I want to welcome everyone, first of all, to my webinar here. It's obviously the title's How to Tell if There's an Operating System Memory Shortage, but, we're Oracle DBAs here, so obviously there's going to be, some Oracle involved in this as well. So, hey, real quick, I need to tell you this. Okay, you are being recorded. So even though you can't see chats, I can, and I'm recording my entire screen. So whether it's a question, a comment, or anything, it's all, okay? There's no anonymous activity here. So I just want you all to be aware of that, okay? But I love it when people type and ask questions or interact and all that kind of thing. So stay by your keyboards and just, answer questions, ask questions, things like that. So I don't forget, at the very end, I will stay as long as people have questions. Okay, I don't mind doing that at all. So welcome again. So I wonder how many of you is the first time you've ever been to one of my webinars? Anybody there? Just type in answer to a question or something like that. Yeah. We got yes, got a couple. I guess Josh. Oh wow, we got a lot of you guys. Oh, that's fantastic. That's good. Good. Well, I hope you really enjoy this thing, man. Okay, so where are you all from? I know we got Thailand and we have Sudan. Now, I don't think anybody can beat that. We have anybody in Europe right now? Okay, we got New York City. You guys can't see the answers to the questions, I don't think. So we got Cincinnati, New York City, California, Philadelphia, Seattle, which is pretty close to me. I'm in the state of Oregon in the Northwest. Got India, D.C., Wichita, Indianapolis, Minnesota. Wow, they're streaming in here. Idaho, Sudan again, Sao Paulo, fantastic. I got some very enthusiastic OraPub members in Brazil. And boring London, fantastic. Slovenia, all right. I still have never been to Slovenia. Dang, ticks me off. I really want to go there bad. I heard it's gorgeous. New Jersey, let's see, Prague, Oregon. Where in Oregon? That's Tiffany. I think that's how you pronounce that. Windsor, Canada, Toronto, Tennessee, Nashville, France, Austria. Martin, welcome. Saudi Arabia, fantastic. Man, I got like some new members in Saudi Arabia. So word is getting out that OraPub is around in Saudi Arabia. That's pretty cool. Some France, Buffalo, Green Bay, Dallas. Okay, I got to summarize here. Vancouver, sunny Florida. Yeah, it's not sunny right now. In fact, I need to tell you, we got a storm blowing and I could have like winds 60 miles an hour, and I'm kind of live in a rural area, so I could completely lose power, okay? If it's just internet, just stay tight, and I have a backup hotspot ready to go, and I may be able to get back online, okay? So give me 10 minutes if I just go dark here, okay? Charlotte, Eugene from, University of Oregon, fantastic. Oh, that's good. All right, Salt Lake City, Chennai, India. Man, we got guys from all over the place. Oh, that's pretty cool. All right. Well, let's go ahead and get started then. And I'll ask you some other questions along the way. Yeah. Oh, how many of you are going to Collaborate? Anybody going to Collaborate? You guys are all over the world, so I'm sure some of you are not going to be going to Collaborate, though. I'm going to be there. I got two quick tips and at least two presentations, so pretty excited about that. We got a next year. We got a couple yeses. Fantastic. Yeah, hey, if you guys are going to be there, I'd love to hang out with you. I mean, it's really a treat when somebody says, hello, Craig, and, it's pretty neat. All right. So a few of you, not that many though. Man, I don't get that. That is my favorite conference, man. I love Collaborate. I love it. All right. So, hey, let's go ahead and get started. So here's the, sign up. I got to tell you guys this. If you guys want to know when my other webinar is on, you click sign up, right, on my webpage, and then you'll see it says, there's the OraPub How-To Tuning Webinars. Check that box. And then regardless of whether you're an OraPub member or not, you will get an email about all the webinars, and then you just look for the ones that are public, okay, like this one. And so everybody on my list found out about this email, whether or not they're on IOUG's list, okay? So, and I'll tell you the big new thing coming up here is I'm just starting to do live virtual classes. I did some for Oracle University a couple weeks ago from midnight to 8 a.m. It was killer, man, but they went really good. So I'm rolling out some classes. There's one of them already available, and tomorrow morning you should see two other live full-on classes. So if you sign up for that list for the LVC, the Live Virtual Classrooms, you will find out about that when those are launched. So I'm pretty excited about that. Okay, here's the situation. Okay, so an operating system memory shortage, right, can cause it's very strange and intense performance situations. Yeah, I'm going to make my picture smaller. It's really distracting me right now. Okay, here we go. And we will be able to see this when bad memory situations happen. It's just really weird, and it's pretty much unpredictable. In my experience, performance, situation that you're going to find yourself in. So what I want to do, I want to show you guys different ways to tell if there's a memory shortage or if you're getting close to that. And we're going to see how that affects Oracle processes. And so to do this, I have this really simple shell script that I just found on Google, right? Slightly modified it. And we're going to slowly increase the memory. Now, it's not like super slow. It's going to happen pretty quick because I'm running on a small VM, so I can have a lot of control over this. But you're going to see what happens as we increase the memory, okay? So we're going to watch what happens. We're going to use vmstat. We're going to use iostat. You might be wondering, well, why are we using iostat? Okay, we're going to look at top and then SAR commands as well. Okay, SAR in particular looking at the virtual memory activity. Okay. And then I'm going to be monitoring the active Oracle sessions. You'll see that using a script you guys can just download. It's in one of my toolkits. And we are not going to look at this key SQL statement elapsed times. And I'll tell you, the reason is because when there's an intense performance situation, the performance it's just so bad. It's like things just lock up and hang. And it's so bad, I can't even gather good Oracle metrics, right? So gathering elapsed times is just really ridiculous. So what I'm going to do is I am going to grab the executions per second, and we'll be able to see that change as the memory situation happens. Okay, so you're going to see, oh yeah, the memory bottleneck. I actually stopped using the word bottleneck because it really offends people, I've noticed. So I use memory pressure now is the politically correct way to talk about that. So hey, by the way, if you have any questions, go ahead and chat those in. I'm always looking at those, okay? At least I try. And if I don't answer it right away, I will, okay? Or at least I'll give it a try. Okay, so you guys, my name's Craig, right? I'm a longtime Oracle DBA, and my specialty is Oracle Database Performance and Predictive Analysis. And I'm excited about the online training because I'm going to get to do my forecasting classes again, which I'm really stoked about that. Do a lot of performance research, and I put that on my blog. And the reason I have not put out a blog in almost a month is because we're wrapping up for these new online classes. So I've got a couple books, new covers, same content. So don't order them again. It's the same content, just new, really cool covers. And do a lot of conference speaking, teacher and mentor. And I'm also an Oracle ACE director, which is pretty cool. So if you're wondering about what is OraPub, okay, we're all about Oracle database performance. And it's like I serve Oracle DBAs who want to take their tuning skills up to the next level. So my goal is to help people like you, right, solve the most nastiest Oracle database performance problems in the world. Okay, and we do that a bunch of ways actually, through webinars like this, through different types of training. And I have a membership program, so I can actually put food on my table when I do this kind of stuff. And here's some of the things that you get as a member. So all my really primo content I reserve just for the members, and they get all sorts of special attention, like a Slack group and things like that. So, okay, so now here's some of the key knowledge. All right, you like that picture? That's supposed to be me, right? Because I got the goat right there. Hopefully your eyes don't bug out like this. Okay, so we're going to talk about memory. Okay, we're going to talk about memory, obviously. So there's two, I'll say, main types or just memory areas that we as Oracle DBAs, we need to be very aware of. And of course, you know, the first one, the big one everybody knows about is Oracle's SGA, right? The System Global Area, right? That's the big one right there. But then what we forget about a lot of times is all the Oracle processes, okay? And call this like a foreground process, which is actually the Oracle executable right here. And it's going to have some PGA memory, right, to do sorting, things like that. So it will have memory associated with it, as well as the background processes down here. Okay, they're going to have memory associated, or they're going to have memory as well. Okay, so there's going to be kind of like two different types of memory here. Okay, so I want to talk about the SGA first. Okay, so what Okay, what I do a lot of times, I'll type questions in and you guys type in the answer, okay? It kind of slows things down a little bit so I can actually breathe, right? Okay, so what do we call the memory that the SGA uses? Okay, there's a special term for that, okay? And you guys probably know this. It just might not be a different way to actually say this. So go ahead and type that in. Type that in the chat or the question answer. So what do we call the memory that the SGA uses? Okay. Somebody go ahead and type that in. Come on now. You guys are really, come on now. We got a lot of you. Oh, here we go. No, okay, we got some answers here. Here we go. Got it. Oh, you know what? It's because I had so many responses that scrolled by me and I didn't even notice it. Holy cow. Man, I'm so sorry about that. I'm like, come on, you guys, say something. And you're like, we're saying it, Craig. Yeah. Oh my gosh. This is ridiculous. I can't even get rid of all these things here. Okay. Yeah, okay. Shared memory segments, right? Shared memory segments. Yeah. Shared memory. That's what we're talking about right here. Okay. And so do you have an idea? What can we use? What's the command to actually see those? The OS command to see the info. Okay. When I mean I mean the shared memory stuff. Okay. We got yes, exact. Okay, here we go. So I have an Oracle instance running right now. Okay. And I'm just going to break. What was I running there? Oh, that was my SAR. I want to keep that going here. I got like a gazillion windows open right now because we're going to need these. All right. IPCS and -M is a really good one to see just the shared memory segments right here. Okay. So if I did shut down the Oracle instance, which I'm not going to, but if I did, right, this, because we don't have time to do that, this would all be gone right here. So you can see Oracle has some shared memory segments. They are the owner. And the permissions is what's interesting here. This is the permissions. The 6 allows other Oracle processes, right, owned by Oracle, to actually read and write to the SGA. And that's what makes it shared memory. So that's pretty cool, right? And we can actually add up and figure out how much and all that kind of stuff. But I'm not actually going to do that. So one way you can tell, like if there's other Oracle instances, you will actually see like a bunch more here as well. And there's a lot more you can do with that command, but we're actually not going to be doing that right now. Okay. So that's how you can tell about that. Now that's the SGA. But let's talk about the process memory, because really that's what's going to be important to us, because there's only one SGA. Right? But there's a lot of Oracle processes. And this can be actually really confusing to people. And so I'm hoping this one slide will help. Now I only have like a few slides. I think, yeah, that's it. These 2 slides, right? So if you want to screenshot this, go ahead and do that. I'll make sure you can screenshot a bunch of like some of the scripts I'm going to use and stuff like this. Let's see, question. So is free, the -M summary. No, I think that's just what's reserved. I think that's just reserved. Oh, you mean when it says free? Or the bytes? I'm not sure. I actually don't know what these are. Don't know what those are. Yep. Excellent responses, you guys. All right, so we have a process, and we can see processes, right? A number of ways we can see that. One way is by running the top command, right? And that's all, right? If you're not, most of you guys are familiar with that. I just run top, boom, and boom, there we go. And I'd use the letter C. I'm going to press the letter C right now, boom, and I get some more command detail right here, okay? So these are all, of course, processes, and so process itself, it's gonna share memory with other processes, okay, and it can have its own private memory, okay? So the shared memory is going to be like the SGA. It can access the shared memory segments, okay, which is kind of a special memory in a way. And then it's going to share the Oracle executable, okay? And we can see how much of this there is if we're really good at understanding the output from PMAP. And I'm going to run the PMAP command. That is on Linux the way to get process level memory information. So if you ever wondered how much memory a process is actually consuming, like at that moment, at that moment, you want to use the pmap command. And I'm going to show you that in just a couple minutes. Okay. So this is the shared memory. Okay. Most processes are going to have some kind of shared memory that they're accessing. Oracle processes for sure. But all processes are going to have some kind of private memory also. So from an Oracle perspective, think about the private memory like our PGA memory. Okay, this is just associated with this process, and other processes can't access it. So that's going to be like our private memory. Okay, and again, we can see that in the pmap output. And when we run pmap, you'll see some of the memory like tagged or named as anon, however you want to pronounce that, and stack. Okay, anon is like, if you're familiar with the C programming language and you've done the malloc command, you're going to see that memory is classified as anon. It's probably anonymous. I'm not sure where that actually came from. Okay, so that's from a process perspective. Okay, now this is what really messes people up. Okay, so you have a process that has memory, but like on the other side though, that memory related to a process can either be real or virtual, right? So the real memory is the stuff that's in RAM, okay? RAM. And that's really important from an Oracle perspective because this real memory, that's private memory, right? That's super important because if I have a lot of processes with a lot of private memory, that's real memory, we could have a memory shortage pretty soon if that keeps multiplying, okay? Whereas if it's shared memory, like the SGA, we just have one of those. It's not such a big deal, even though it's a huge chunk. Okay, so the key word here, okay, is shared memory. It's not shared. It's the resident. I got to spell this now. Resident set size, and you'll see that as RSS sometimes or RES. Okay, like the top command here. Well, actually, I'll show you this. You see, these are all your processes. See the RES right here? That's that resident set size right there. So what it's saying is this process right now is consuming at this moment in real memory, like we're talking chips, right? Not on disk, not virtual. This is real memory at this time, around 97 megabytes right here. And this real memory, and so that'll change. That'll go up and down. And this is going to be primarily, right, it's going to be the PGA memory is what makes most of that up. Okay, so this is the real private memory right here we're talking about. Okay, all right. Now the virtual memory, of course, is the stuff that is kind of, we don't have room for it in memory, and the OS is going to put some of that memory out to disk. Okay, and we can see that, and that is really one of the key focuses of this webinar, is to figure out if we're going to have virtual memory problems. Okay, and we can actually, we're going to use SAR, vmstat, you know what, we're going to use iostat also in a strange kind of way. Okay, and we can actually see the virtual memory situation. And then we're going to see just how horrible performance can actually be. All right. Okay, so I've been monologuing for a while here. You guys have any questions? Let's see. Anonymous. Oh, hey, Kim. Good to see you here. How does huge page affects it? The huge page is going to make sure the memory is like, it should be locked in memory right there. Okay, and I'm really not, you know, an OS expert on this, but I haven't heard anybody tell me that huge pages caused a problem. But it should be locked in memory, so your SGA here, the shared memory segments, don't actually get messed, you know, don't become virtual, which is going to be a horrible situation if part of your SGA gets written out to disk, because you know it's going to have to be read into disk, and then you got I/O related to Oracle caching. I mean, that's just like, you know, it's messed up, and your performance will get really messed up. So, all right. So I do have a little load on the box, and if you're wondering how I get, people ask me about that all the time. So how I do the load, and I have a toolkit on my website, okay, called the OSM Toolkit for OraPub System Monitor. And one of the tools we're going to use, actually it's a different toolkit, dang it, sorry about that. It's called the OraPub Loader. I call this OP Loader. It's a shell script, and there's some few supporting scripts. If you guys actually want to download that, I'm going to get this out of the way right now, okay? Okay. Under Resources, go to Tools, and then the tool at the top is going to be my OSM Toolkit, and I'm going to show you one of the tools today. I'm going to use quite a bit from this toolkit. All right, these are totally free. You can download them. And then where's the OP loader? Load generator right here. And there's where you get that. It's not rocket science, guys. I'm just basic stuff, all right? And I actually use that a lot in my work to get real specific loads on a system. Okay, I don't use things like swing bench and stuff like that because I'm not trying to simulate like real Oracle users. I'm trying to stress Oracle in a really weird way, usually very, very pointed workload that I'm trying to do. Okay, let me take a breath. Any questions? Let me get some water here. Want to make sure we finish the top of the hour here. So, all right. So what I want to do. Okay, no questions coming in. Okay, let's see. Serve virtual. Yeah. Excellent. Okay. All right. So let's get a process and let's run that pmap command on and take a look at it. So we got an Oracle process. We have just a couple different foreground processes. This is one of them right here, and there's the process ID. Okay. So I'm just going to do a pmap. And what's my option? There's some options on this. And this is an OS command, so you can do a man page on it. Really simple. And so here we go. Boom. So at this moment, okay, let me so you guys can see this. There's a lot of different pieces of memory. This is an Oracle process. I don't remember seeing all these. I don't know what the heck this stuff is. But okay, so there's the pmap command. Let me make this a little bit bigger. Ah, there we go. I like that. All right, there's the pmap command. There's the process ID. Okay, there's the resident set size. Okay, that's what we care about. That's the stuff in real memory. Okay, so and here are some of the mappings. Right, this is like to Oracle. This I don't know if that could be the SGA right there that we're associated with, but I don't know. But there's some of the malloc commands or some that's like my private memory. And further on down here, you're going to see a bunch of shared libraries. So we know this is being shared with other processes. We'll see a lot of that. All sorts of different libraries. Pretty cool. I never really study this because what I really care about is at the very bottom of this. Okay, so I'm going to go. That's what I care about right here. Okay, this tells me that this process has around 100 megabytes of memory right now at this particular time. So if you right there's the process, right? It says 99 megabytes. That's pretty darn close. That's like 100 megabytes. So this is real time. So let me do it again. See what we come up with. Boom, 101. It says 99. Okay. What am I going to trust? Am I going to trust top or am I going to trust PMON? I'm trusting PMON. Okay, because PMON's probably getting information from the /proc file system. Well, I know top is too. But this is going to be like the latest and greatest, boom, whatever is in the process tables. Or not the process tables, but whatever information is being stored about the process. So if you ever really want to know the memory and the safest way to get the real answer to the memory that an Oracle process consumes on Linux, use the pmap command. That's what you want to use. Okay? Once you've verified that top tells you the information correctly, then go ahead and just use top if it's actually easier to do that. Okay. Oh, by the way, to sort in top, because maybe you don't want to sort by the default of CPU, maybe you're interested in memory. Okay, you use the capital F, Shift F, that's what I'm pressing, and then here's all the different ways to sort, right? And we want to sort by the resident set size, right? RES here. And so I'm going to type the letter Q right there. Return, and now I'm sorting by memory right here. You can see that, which also happens to be the top CPU process. What a surprise, right? And there we go. So we're still at around 100 megabytes right here. Okay. All right. So I wanted to show you that so you can see what's going on there. So we use top, we sorted, and we used pmap. Okay. Now I want to shift from a process perspective to the operating system because that's really where the craziness. But I know one of you asked me before this seminar how to tell like that runaway process. Well, you can use top to find a runaway memory process, and you can actually get information about, I guess the libraries and information about the memory using the pmap command. And I'm sure there's many other options with pmap, so you can get more detailed information. But that's way out of scope for this one, this topic. or this webinar. Let's see. Are you not seeing my oh, David. Let's see. No, I am seeing them here. Let me see. I need to get my chat window bigger here. Here we go. Whoops. Dang. I can only see, oh, hold on a second. You have a really long question here for me. Okay, it's not that long. David, it used to be Oracle recommendation SGA had to be in one segment. Oh, one memory segment. I don't know. If Oracle recommends it, then do it on that. I mean, it makes sense, right? One segment, but maybe it's more difficult for the OS to actually grab that memory. Don't know. I don't know. Yeah, that, you know what, I would use whatever the current recommendation from Oracle is. And actually, you could ask an operating system person about that, see what they have to say. So, yeah, sorry about that, David. I did not see that question. Let's see. Question. Huge pages. Oh, is it safe to run pmap command against a currently running Oracle process? Check with your OS person first, but I would not think that that would cause any problems at all, because you're just looking at some information about a processing just in a split second. Now, don't loop it, right? Don't do that, but I would think you're going to be okay. Oh, question about using a PS, the PS command, right? I don't like to use the PS. Traditionally, historically, it's been really crappy when it comes to memory. If you verified it with like pmap and top, then go ahead. But the problem is that sometimes in the past, I've been bitten by this, is that it says that, oh, it's like, how much memory is this process associated with? Well, it includes the shared memory, which could include the SGA, which means you're going to double count your memory like crazy if you add up all the processes. So you got to make sure you're actually seeing the resident set size. Okay, so be really, really careful about that, Tom. Okay. Let's see, Curtis, you said something about huge pages. I missed it. Well, I didn't say much. All I said was that if Oracle recommends it, do that. I've never heard anybody tell me when they used huge pages, performance got worse or they had problems. Okay, and you still have to have enough memory. I have heard it. One of my members said, "Hey, huge pages is not working right, man." Well, he got this super tiny server, and he was trying to create an SGA that was like bigger than the actual physical memory, right? So of course you're going to have problems. But that I've heard always said it's actually worked out really good for them. Okay, it doesn't mean you're not going to be the first though, but I would say you're pretty safe with that. Oh man, more questions. Let's see, Greg. Let's see. Does this change running on AIX? Great question. Okay, all bets are off on AIX. All bets are off on AIX. If I have a hint of memory issues, pressure, and I'm on AIX, I immediately go to the OS administrators. Okay, it's a whole different beast on memory. In terms of CPU, it is too, but that's actually understandable a little bit more than the memory is. So the stuff that I'm going to talk about, I don't know how much that's actually going to translate into AIX. Okay, honestly, I don't know how much. Let's see, the resonant set size, is that coming from the PGA? Yes. Mostly, there's going to be some other private memory, but that resonant set sizes should be primarily made up of the PGA. That's right. Don't use automatic memory management with huge pages. David suggests not to do that. Okay. Yeah, I don't know. That's whatever it says. Yeah, or if you've had some bad experiences with that. Okay, let's continue on then. We want to take a look at the operating system, use some OS commands here. Okay, so the first thing I want to do is I'm going to start what's called I call this my real-time session sampler. Yeah, I know it's kind of a silly name, but this is what we're seeing right here. Okay, so how I started this is pretty cool. Okay. Don't run this on your production box. I will say it for sure on this one. But how I did this is there is another window here that's running. Okay, this is it. And I'm going to make this big so you guys can see all this. But this is one of the tools in my OSM toolkit, right, which you can download. And I call it the real-time session sampler. I use this for demos and for webinars all the time because it's like a real-time monitor and it's text-based, so it's just really nice. Basically what I'm looking at here is show me all the active processes and I want to sample every half of a second. And when you run this, then it's gonna just write the output, right, to this file in /temp. And so all I'm doing is a tail-f on that file, and as long as the script is running right here, I'm going to see the output. Okay, and so like if you're not sure if you got anything happening, just like press return a couple times. Oh yeah, and you can see there are some active processes here. Not very many, right? I have a really, really mellow load running on the box right now. And you can see it's the session 27 here is the big session, and this is the SQL ID that it keeps running over and over again. Okay, it's not a long running SQL. It just anyways. So so that's what that is. So we're gonna look at that. That's one of the things we're gonna look at. The other is we're actually gonna look at top, and really what I want to use top for is I want to know. I'm gonna run out of room here. When we start loading up or sucking up memory from the OS, we're going to be able to see that process. And so I want to be able to see this top process. We're going to want to do that. Okay. Also, we're going to use, let me see. How am I going to do this? All right. I'm going to move some stuff around here. Whoa. That's me. I'm going to do that. I'm going to put myself down here. We're going to have top here. We got a lot of questions. All right, I'm going to shrink this box here. Let's see. Okay. Oh, other. Okay, I'm going to go back to the questions just a minute. I want to explain the different windows. So you know about top. In fact, all I really need to know about top is, I'm going to shrink it down a little bit, is really just at the very top. Okay, what I'm running here, okay, this is a SAR dash, it's a capital B. Now you always want to check your man pages when you run SAR, but this is how I get information about, from an operating system perspective, about the virtual memory. Okay, so I'm taking sample every 2 seconds, which is unusual, but I want to see things happen really quick when I start loading up the box. Usually I do like every 5 seconds or 10 if I'm just looking at stuff. And I want this thing to run like forever. So here's the output, okay? There's a lot of different stats here. Do a man page. You can get more information on all of these, okay? But what I really care about, what I look at is, well, I'll tell you, the one I really care about the most is this page scans per second right here, okay? In fact, this is, when it comes to memory, except for one statistic where 0 is good and non-zero is bad, which is excellent to know that, most of these here will have non-zero values. And so what is okay and what's not okay, you've got to figure that out on your box. And it's, if you sometimes have memory issues, or you think you do, right, and the phone starts ringing and you get really weird performance situations, you'll notice that your memory will kind of spike up then. And it kind of makes sense. Oh, okay, this is not a good number when I've crossed this threshold. If you haven't hit that yet, the best thing to do is actually to talk to your OS admin, and they probably have a pretty good idea what's acceptable values for you. Okay, but what I do is I look for the stats that are 0 when it's good, non-zero bad. Excuse me. So here's the page scans per second on this Linux box. Hold on, I gotta mute myself here. There we go. Thank you. Sorry about that, guys. Oh boy. All right, so we got our pages scans per second. That's going to be 0 when things are good, and it's going to wham flip to non-zero when we have bad things. So that's a good one to look at. Okay, these are blocks that are paged out, blocks of memory in the OS page out to disk. Okay, so you'll see there's always some activity, but you'll notice when things get bad, we're going to see it spike up. Okay. So the faults is when a process needs memory, but it needs a block of memory, and it's going to have to get it from like another process, or it's got to take a block of memory, write it to disk, and then in a sense it can then use that block. So there's I/O associated with that, and that when it has to go to disk, when it has to write a block out to disk, that's called a major fault, not just a minor fault. Okay, so what you're going to see here is that when this major fault, we start getting non-zero values, we know there is some significant memory pressure, and the OS is starting to have to use the virtual memory subsystem and get some of the real memory blocks and write those to disk to free up other memory, to free up other blocks of real memory. Okay, so those are the ones I really look at. I'm going to look at the major faults right here. I'm going to look at the pages scanned per second. And you'll notice that the faults are going to start to kick up when things get really bad too. Okay, so that's SAR. Okay, vmstat is my favorite for this. And vmstat, it's really rare for DVA not to have access to vmstat. It's like the go-to, and it takes a little bit of overhead, so most admins don't even care that you're running vmstat. Okay, so I have a 2-core box. Okay, I want to tell you that's important because if my number of process, that's the far left column here, the R right here, okay, if that hits above 2, my CPU utilization can easily hit 100% on this little VM that I'm running on right here. Okay, and what I want you to notice here, there's one key column. Okay, this is the column of any place that I look at to tell if I have a shortage of memory. Okay, I look at the SO column. That stands for blocks swapped out per second. Okay, the SO column, you always want that to be 0. Okay, now don't get in an argument with anybody about, oh yeah, the OS doesn't swap out processes. Okay, I don't care what anybody says, but for sure blocks do get paged out to disk. Okay, and I know that when this column is non-zero, the really bad stuff is going to happen. So this is the column. 0 is good, non-zero is bad. Okay, and if you'll know, those of you who have had memory issues, you're going to notice, hey, it's 0, and all of a sudden you start getting some small numbers. It's like, uh-oh, and then some bigger numbers. Oh crap, the phone's ringing. I mean, that's how it works. The other thing to look for is you see this free memory column right here. Okay, that as we start to consume memory, we will see that start to drop. And then that's okay, but there's like a threshold. And the OS guys know what that threshold is because that's a kernel parameter. And when it crosses that threshold, that's when the OS says, whoa, we got a problem here. And that's when you start to see the swapping kick in. And as soon as you see non-zero numbers there, you should see the free memory jump back up. But if it's not enough swapping to increase that free memory, it will swap some more. Okay, and we're going to see that happen when I start putting the load on the box. Okay, so really for vmstat, I look at free memory just to give me an indication of kind of how the ebb and flow is going, and I look at the SO column on this. Okay, all right. So let's see, what else did we look at? vmstat. We looked at SAR. We got top. Oh, iostat. I wanted to show you iostat. Let's see. I have an iostat here somewhere. Here we go. Here we go. Okay, I'm going to make this a little bigger. Now I have this is not a real system, right, guys? Because I can't do this with somebody's production system, right? So I have basically one device. Actually, I have one device. This is on a virtual machine. So just look at the utilization column here. That's all I really want to focus on. And you'll notice right now the utilization is it's about 0. There's hardly any activity. What you're going to notice when there is significant virtual memory activity, the I/O subsystem will have to get involved because those pages that were in real memory, we're going to have to write those to disk to free up other pages of real memory for other processes. And that I/O, if it's intense enough, can actually start stressing the I/O subsystem. I mean, it's crazy. You have like an I/O bottleneck, right? A disk that's getting the crud beat out of it because we're out of memory. So then you can get like DB file sequential reads and wait events like that because we're beating the crap out of your I/O subsystem. Kind of bizarre, but we should see some of that. Okay, I think that is, and then we're going to look from an Oracle perspective. I have another window for that here. I should be in SQL Plus here someplace. Yeah, this is the one I'm going to use for that. Okay. All right. Is what I have here, going to System Manager here, and I have a little script right here that's going to give me, basically it's going to give me the execution rate. Okay, and so just a little bit of PL SQL. I'll show you that real quick because it's not rocket science. Okay, in fact, I don't want to execute it yet. Hold on a second. I just want to show you the PL SQL. Okay. All right, so I'm going to paste that in there. Come on. Ugh. You guys can see that? Yeah, pretty much. All right. All right, you guys still, everybody's still there? Oh yeah, hey, let me go through, let Let me show you this, and then I'll answer some questions. I know there's a bunch of questions that have been built up. Okay, I got to set my server output on. Essentially what I'm going to do, I'm going to take 20 samples, and each sample is going to last just for 2 seconds, so it's pretty quick. So I want to get a number of samples, and the reason is we want to see what happens to the execution rate as the memory situation gets really, really bad. Okay, so all I am doing here is, actually I'm grabbing, I use this for some parsing research that I'm doing too, but really what I'm looking for is I want to select the value, where the statistic, let me back up. I want to get the value of the execution count from $vmstat. Okay, so I'm going to get it at the begin right here, and I'm also going to get it at the end right here. I'm going to calculate the delta, the difference between the current value and the beginning value, and I'm going to divide by my sleep time. So this is going to give me the executions per second. Okay, and I'm going to take 20 samples of that. So that's what this is all about. So let me see if this will actually run good. Okay, it's just running. So I want to show you that. Okay, let me go answer some questions, and we'll start this thing running here. Let's see here. Let's see. Huge pages. Yeah. Is there? Yeah. AIX. All bets are off. Let's see. Yeah. Thank you. Oh, ASMM does not work with huge pages. I said, okay. All right. So check out huge pages. Make sure you're able to use that. Cool. All right. All right, somebody has a script that will give you this information for HP, UX, and for AIX also. They're out there. You can do a Google search on those. I'm sure you're going to find it. Yes, this is all being recorded. It will be on my website. You will see the questions and everything on my website in the video. You know, me talking on IOUG will also have a recording of this as well. Okay, so I will put mine up. And if you are on my webinar list, right, you sign up for that, then you will get an email that says, hey, I just posted the video. Okay, and I'll get that online later today. Let's see, okay. Yeah, it's the memory that drives I/O high. Yes, if there's a lot of memory pressure, the I/O subsystem has to get involved. That's just part of the virtual memory subsystem, right? And you'll see more memory intensity, pressure, you'll see more I/O activity wherever the temporary file system is at. You know, your swap area and things like that. Yeah, wherever your swap area is at that you defined, like when you set up the box, or you added swap when you installed Oracle. Okay, this is what drives memory high. A big PGA, a lot of PGA memory. And depending on how you have Oracle configured, okay. Don't use memory target. Yeah, okay. All right. Yeah. Okay. A lot of stuff about huge pages. Just check it out. Make sure it's okay for you and your OS and how you've got Oracle configured. Okay. Okay. Good. Excellent. Okay. Let's move on here. So what I'm going to do now is I'm going to put a memory load on the system. We're going to see this thing just go berserk, and then we're going to go back and we're going to take a look and see what happened. Okay, so I have a little script here that is really bad. Don't run this script on your production box, please. If you do not call me, because I told you don't run it. All right, I'm sure you guys wouldn't do that. Okay, this is what it is right here. I'm going to do this like 50 times. Okay, and each time is that I'm basically going to suck up a bunch of memory. How much memory? This is how that's defined right here. Okay, that's the bytes. Okay, so this is going to be like 1 gigabyte, something like that here each time. And I'm going to do this 50 times. And this is the key command right here. Don't ask me to understand that, but it works. Okay, this thing will suck up huge amounts of memory very fastly if you let it. Okay, and on this little virtual machine, it happens pretty darn quick. So we're going to run this, and I'm going to. In fact, if you're interested, just screenshot that right now. Click. Okay, you got it. And I'm going to shrink this down a little bit here because that's really not what's going to be important. So we want to get everything ready as best we can here. All right, so we're going to put this down here. We have way too much stuff. Okay, the real-time session sampler. I'm going to put this up here what I'm looking for there is to see if we get any IO wait events, or we have like the timing profile changes, that kind of thing. Okay, there is, whoops. Oh, I actually got to start the SART command going. Good, good, good. Got that. And then the IO subsystem stuff is down here. Okay, so you'll notice we're going to start getting here. I'm just going to put that right here. Sorry about there's so many windows. Hope you guys are okay with that. All right, you guys ready to go? Type yeah, man. I'm ready to go. We're going to pull the trigger here. Yes, I got a couple yay. Okay, good, ready to go. Here we go. So, and what I'm going to do is, remember we have our PL SQL here. I'm going to start that. Boom, we're going to wait a couple seconds. So we get a couple samples when things are just kind of cruising. Everybody's happy. Everything's good. Okay, here we go. Boom, done. All right, so let's watch and see what happens here. The quickest thing is to look at you'll see the free memory here start to drop. See it dropping? Starts to dropping. Where's my vmstat? Where's my vmstat? Oh, this is my vmstat. Okay, it's dropping. Okay, good. It's starting to drop. Drops more. Okay. All right, all right. Okay, now we got some other numbers here. Let's see. We're going to see some page scans start to kick up. Okay, virtual memory is doing really good. This is going a little slower than it usually does here. I want to be able to see. There we go. Okay, it's dropping. Now it's starting to drop. Boom, there's our first swap out right there. Okay, we should see some okay, look at the utilization on the disk over here. See that? 88%. That's because we got a lot. Look at the swap outs right here. Okay, notice we completely, we can't even start up a process right here. Okay, let's see what else is going on right here. Oh, look at all the numbers. It's going crazy right here. Okay, we're going to stop this now. What's going to happen? I will stop this and we will go through this. Okay, so don't panic. This should kind of mellow out for a second. Okay, the shared memory or the free memory should start to go up and the swapping stops. Okay, okay, so this thing is going to loop around again. Okay, 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 let's just, okay, now it's going to start to get bad. We're starting to swap again. All right, we're going to let this go one time more and then we'll kind of check this out. But you can see when things are good, when things are bad. All right. I love it when 0 is good, non-zero is bad. Okay. Oh, by the way, we can tell the big process right here. This is it. This is my command. You see the grep in? It says we're taking about 1.4 gigabytes right now. That's what we're consuming. This is not an Oracle process, right? This is being run straight from the OS right here. Okay. All right. So I'm gonna go ahead and stop this right now. Okay. And I actually want to get. Oh, notice that everything's just going to kind of calm down. Free memory goes back up, swapping stops, IO subsystem back to 0. Where was it? It was 85, 90%. Oh, everything's 23%. Oh, everything's good. Thank you, Craig. Kind of thing. Here, everything's back to 0. We're all cool. Okay. Now, I want to take samples again here when everything is mellow. So this is the execution rate. So when we started this thing, or I had a couple rounds here where I hadn't stressed the system yet. And you can see I stressed it. And look at the execution rate. It plummeted. Right? We got 100 right here, 83, 79. I'm surprised it's not even worse than that. So I'm going to run this. We're going to see what the numbers are going to be when everything's really cool. Okay. All right. So while that's actually sampling, let's take a look at see what's going on here. Okay. So I'm going to stop vmstat right now. In fact, I'm going to stop all of these right now. I think those are the key things. All right, so let's look at vmstat. Let's take a look at this. If you have any questions, go ahead and type those in. Oh, we got some questions here. Yeah, rocket. I love doing this kind of stuff, man. All right, so I started adding memory pressure. Okay, it's like we have a big, the max allocated PJ size is like huge, right? And all of a sudden, you have a lot of Oracle sessions, and they actually start using that, which means there's going to be a lot of mallocs going on, right? This is not shared memory segments. This is not the SGA. So if we give Oracle a huge amount of space for the PGA and we get a bunch of processes, it's going to let us use that. And we can put a tremendous pressure on the OS here. And so you can see here, like let me get where things were good. Okay, so things were good here, right? Everybody's happy, you know, we're all good. A bunch of memory here, and you can see it start dropping right here. See, you start dropping. And things are okay. See, the OS is okay at this point. There's enough memory. Okay, but at some point though, the OS starts saying, whoa, I don't have enough real memory here to satisfy the demand for the memory, the real memory. And so it's going to have to take some blocks and write them out to disk. And when that gets intense enough, we see the swap out column go non-zero. Okay, so on an Oracle database system, okay, you should always have zeros here. Okay, you will normally see zeros. But if you see a huge drop in memory here, the virtual memory subsystem has to kick in. And what normally happens is that if that just happened like kind of weirdly or randomly, you'll see a little bit of swap outs here. And then you'll see the free memory jump back up because the swapping gave us some actual free real memory for those processes to use. Everybody's good, you know, we're all happy. But in this situation, I kept just beating the crud out of the OS. And it was like I was relentless. And even with the swapping, it couldn't get the free memory value up high enough. Okay? Until finally, when I backed off, you can see it starts backing off, and now you see the free memory jumps up, and the swapping goes back to zero right here. Okay, but sure enough, what do? I start sucking up more memory, and you can see now we go from the 6, 4, 3, 2, right? 1, we got 17 something, 11 something, 5 something, 2 something, about 1.6, and the OS says, hey, that's too low. It starts to panic. You got to be careful when you use the word panic. It gets a little stressed, feels the pressure, and it starts swapping. And what the OS wants to have happen is it wants to get this free memory back up, but it can't because I'm just so relentless. Okay, so that's why vmstat is so powerful, because you can actually kind of see the correlation between the free memories dropping and then the swapping actually takes place. I think there is another option too, and for SAR to actually show me the swap outs per second. I don't know why I didn't actually. I think there's an option for that. Okay. All right. So if let's take a look now at this is the SAR command right here. I use -B, capital B for this right here. Okay. And let's look at when things are pretty cool. Okay. So things are good right here, and you can kind of see this is where they get bad. Okay. So this is where they're good. All right, so you can see the page outs per second, right? There's always, virtual memory is a normal part of activity. So you're going to see some I/O. You're going to see some of these major faults. I mean, I see that on Oracle systems. But notice the scan rate is 0 right here. Okay, so I'm going to see that 0. And then we're going to start seeing the scan rate start to increase right here. Okay, we've got not only is it non-zero, it's starting to increase. So what I see in systems is I'll see that scan rate kind of kick up a little bit, and then it'll go back to 0, or it'll kick up and it'll go down really low. And so it's like everything is good. It does what it needs to do. Everything is back to being okay. But what I was doing though, because I was just putting so much pressure on it, it's like it couldn't recover, and it just had to keep scanning. Had to get super aggressive right here. Page scans per second. Okay, so this is why I like this indicator, this page scans per second, because I see a lot of zeros when things are actually good. All right, but you can see how the other stats change as well. Okay, but the page outs is a good one because you have more digits, that kind of thing. All right, so that's SAR, and I'm sure there's other options in SAR to do this as well. I think one of the most interesting, and which gives us a deeper understanding, is by looking at the I/O subsystem. Okay. Now, on your Oracle systems, where the swap or where the writing, the paging out to disk is taking place, that's probably a mystery to most of us as Oracle DBAs, because the I/O subsystem is being managed by people we've never met before, don't talk to, and it's just supposed to work. It's kind of like the cloud, right? It's just supposed to work. So, but what you'll notice as somebody who's watching this and actually looking at the devices, they will see an increase in the I/O subsystem activity, specifically where these blocks all right, are being written out to disk right here, all these page outs to disk. Okay, and we saw that because, right, we saw things are looking really good. Where did they get bad? Here we go. Yeah, things were, let me go back where they were good here, because they were bad for quite a while here. Come on, there we go. Things are good, right? Like 0% utilized. Hey, no big deal. Everything's good. We got some 3%, and then boom, we're like practically at 80%. Okay, and that is only because it's not because of the load that it's not because of the Oracle load is doing a lot of reads because it can't find blocks in the buffer cache. This is a different thing, right? This is not an Oracle server process saying, hey, is my block in the buffer cache? And the answer is no, I got to go get it from the IO subsystem. This is totally different, right? This is why, like, I don't see like sequential reads and stuff when the bad stuff was happening. Okay, now the timing profile can change, right? We noticed that the process were having a problem actually starting. It was like taking too long for processes to start. There were some really unusual wait events there. Okay, all right. So the other thing, okay, and then I'll go ahead and answer some questions here because we're getting close to the end game. I hope this is making sense. This is kind of a scattered, just looking at different things webinar, but I'm not sure how else to put it together. So this was when when was the bad stuff happening? The bad stuff happening was right here. This is where the execution rate really started to drop on us. Okay, when things are good, right here, things are actually pretty good. We got 130, right, executions per second. We're in the 120s right here, 150. And usually, when I was doing this yesterday, I got numbers that were a lot higher. And then when I have the memory pressure, you notice the numbers dropped. We had 70s, 80s right here, 70 or about 80. So we were kind of in the 80s and the 90s. We were well above 100. So, and in fact, I'm gonna put the load on here again. Okay, and I actually want to see. I want this thing to really get bad here again. I know you're waiting for me to do this again. All right, so we'll let that go. Okay, I'm gonna start this because I actually want to see it get worse. Because what I want you to see is that when the memory pressure gets so bad and the IO subsystem has to get significantly involved, virtual memory is really active, is that what can happen to Oracle processes? It's like it's unpredictable. You don't know. And I mean, just it's people say, well, what happens to Oracle? Things just kind of freeze up. It's almost like a lock, right? Somebody's screen can just freeze and then it's okay. And that freeze, it can actually, last for not just a split second, but for seconds, or if it's crazy bad, it could actually lock up maybe for a minute, but that's, I don't know if I've ever experienced that, right? But you get these really weird performance behaviors. It's just super intense, unpredictable. It's like you get screen freezes kind of stuff. And I wish you could kind of see this, but sometimes what happens when I run a demo like this, it's like all of a sudden all my monitors, they just stop reporting for seconds, and then boom, everything comes back to life. And that's a classic memory system, because the operating system just gets like boom, it gets hammered. And it's just like, whoa, what was that, Craig? Stop that. You're putting too much pressure on me. And it has to recover. And everything just stops while it's recovering. And then it recovers a little bit. It starts reporting even the stats. So that's why you can get some really weird numbers like in your AWR reports, your stats pack reports, because Oracle can't even gather the metrics to tell you what's going on. Okay, Ash is probably your best bet because it is built to never stop. No latches. No locks with Ash. That's probably your best bet, but it might not even work. Okay, at the end here, okay, now this is what I want you to see. Look at the executions per second, what it dropped this time. Okay, it plummeted. This is crazy. We got we're like under 10 executions per second, multiple samples of this before we are clearly over 100, 120. So you'll see like your throughput just plummet when you get this kind of situation. Okay, so that's kind of it from me here. Let me finish up and then I'll answer some questions here. Okay, so I wanted to show you that. Let the typing be. Oh, hey, if you guys need to communicate with me, you can always email me. If you're an OraPub member, we have a Slack group, which is we can get really other people besides me chime in all the time. It's pretty active. I'm on LinkedIn. Connect with me on LinkedIn. We actually have a Facebook page too. And if you want to see when the next webinars are and when I get this posted so anybody else can watch it, just get on the How to Tuning webinar list. And if you want to know when my new online virtual training is going to happen, those classes, just sign up on that list as well. Okay. And I think that's all I have there. Okay, so let's look at the questions here. Okay. Hey, those of you that have got to go because it's at the top of the hour now, hey, thank you for joining us. I hope you really enjoyed this. You got some value out of it. I know those of you that are on AIX are like, what? You know, how does this relate? It's difficult. Okay, AIX is a different beast, but you still have the same general concept, right? You have real memory and you have virtual memory. You know, same kind of idea. Okay, so let's go to the questions. All right. Okay, I got all the yeah. Let's do it. Nuke it from orbit. Wow. Okay, you guys are getting pretty aggressive, Kevin. All right. Let's see. How much is your PJ configured for? Oh, you're welcome. Or not. You thanked me for. I'm getting ahead of myself. You thanked me for answering your question. All right. So what's my PGA set at right now? I want to think I have a little PGA script right here. Unable to open that. Okay. What I do is it. Is it show PGA? No. What's it? Show parameter. Let's see if I got a PGA parameter right here. It's not going to be big. The aggregate limit, the target, my target's 0. Okay, so it's 2 gig. It's not big. Remember, this is a tiny Oracle instance on a little virtual machine. Okay, so and if I wanted to make the situation worse, right, I just crank down the maximum on my memory that I'm allowing for. All right, let's see. Why is the major faults dropping? Why isn't it dropping that much? You know what? You're saying why isn't it dropping? So okay, this came from Chris. Can you rephrase that? Because I can see here's the major faults when things are good, right? It's 0. It kicks up, right? And when things start to mellow out, right, then it does start to go down. Okay. But there's still, I wonder if it kind of gets behind. I'm kind of guessing. Maybe it gets behind and it has to kind of catch up. I don't know. Obviously, I don't know the real answer to that one. Okay. Does automatic memory management handle SGA and PGA? Oh, okay. Does automatic memory management, does it do good? Does it work well with the PGA and the SGA? Yeah. I think it does. It does. It didn't used to, but I think I'm pretty comfortable with it now, assuming you have minimum thresholds. Okay, you need to do that, like on your buffer cache and your share pool. You got to put minimum thresholds because hey, Oracle is written by people, and there's like all these weird edge cases and stuff like that, and you're going to want Oracle to have a specified minimum so it doesn't get itself in trouble. So hey, I forgot to. There's a couple other questions I wanted to ask you guys. Darn it. This is kind of this is the takeaway right here. Okay, what are some of the ways? Okay, we know when there is too much memory pressure. Okay, this is like a review here. Okay, what are some of the ways that we can tell? Okay, so those of you that are still here, think about that, and I'll start answering some questions here. This is kind of like, did you actually learn anything? Question here. Okay. Let's see. Question. Here's my question. Gives virtual memory pages. Okay. Anytime. So, okay, David, you asked a question like, how does Oracle get this memory information? Okay. Anytime you see any information from Oracle about the operating system, okay, I'm assuming that's what you're asking here. It's getting this information from a virtual file system called /proc. Okay. And if this is really cool. You guys ought to go to /proc. Solaris has this and Linux has this. I don't know if AIX has this as well or not. But if you do an LS on /proc, these are all the process IDs. We can get information about memory info, right? Information about all your devices, CPU stuff. I mean, and this is like live and it changes. So this is where vmstat and this is where SAR gets its data from this /proc file system. Okay, I've actually traced Oracle background processes and the startup of when Oracle instance starts, and it actually gets and it looks at /proc. So that's why I trust the information that's in $os stat, okay, which is also in VBA hist os stat, okay. So if you see things like the virtual memory data that Oracle gets, it's probably okay, but you need to check the memory stuff. I'm still really cautious about though. But that's where it gets it from though, okay. Hopefully that's the right answer to the question. How do you set the upper limit of like PJ aggregate limit? You know what? I don't think there's not like I don't have a rule of thumb for that because every application and workload is different. If you have a lot of sorting, right, you want a lot of PJ memory, okay? In fact, the key to tell if you're having sorting issues is you'll see a wait event like a direct path read temp, right, or direct path read, direct path write temp. Okay, if you see these wait events, if you do your time-based analysis, right, you look at from a DB time perspective, and you have some significant, right, wait time associated with either of these wait events, you know you're doing a lot of sorting to disk. In other words, the sorts can't be done in the PGA. Okay, and so that is your clue that you need, that you want to increase your PGA. Okay, now you got to have the OS memory to support that. Otherwise, you end up in the situation that I showed you. Okay, so you got to watch out for that. All right, hopefully I think that's a good answer on that one. Is there a way to automatically be alerted when memory is just higher? Oh, yeah, you could. I'm sure like some monitoring products, tools like SolarWinds, they might actually have something like that, or you just write something yourself. Is what you would do. What I would, okay, if I was gonna, I mean, the panic when you really start to get like freaked out is when vmstat, that swap outs, if that goes non-zero, I would actually want to know about that on it as a DBA. Yeah, that would be a good one. Also, if the free memory drops, because that's not just a 0 or 1 kind of thing, that kind of gives you a heads up like, hey, we're kind of crossing the threshold. We better look at what's going on. Okay, and what you want to do then is you want to, for example, go to top. You want to sort by memory or by your resident set size and see what processes are sucking up all the memory. Maybe you got a runaway process. Okay, so that's kind of how I would handle that. Let's see what else we have here. SAR-S. Was that what I was looking for? Dang. Is that going to be my swap outs? Percent swap used, swap free used. Yeah, that would give me some indication. I'm looking for per second kind of thing too. All right. Good comparison with the cloud. Yeah, the cloud, you know what? You might not even be able to see something. I do in Oracle's cloud though. You do have quite a bit of access at the operating system level, which is pretty cool. Okay. In fact, I'm going to start doing some of my webinars using the Oracle Cloud. The problem is I can't stress the crud out of the box like this. Otherwise, my trial account, they say, I'm sorry, you've exceeded all your resource consumption, and that's it. Let's see. Oh, what command am I using to get the page steals per second? That was the SAR dash with a capital B. Now, you need to check, that's Linux that I have. I'm using Oracle Enterprise Linux right here is what this is on, but you need to check the man page. There's all sorts of different SAR commands. Wow, we're going long here, guys. Is it worth switching to huge pages? You know what? You got to do more research. I can't answer that. There's just too much. There's too much to consider on that. I'm sorry. I wish I could just give you like a yes/no answer on that. Okay, yeah, lots of them. Let's see, bad stats. I've seen situations where bad Oracle stats, bad SQL plan, can cause PGA saturation. You bet. Yeah, in fact, we can tell in Oracle process. You look at like $PGA stat or something like that. It'll actually tell us which sessions are consuming a lot of memory. $session probably has some information about that as well. Man, you guys got a lot of questions. Okay. Solution. Okay, what's the again about the recommended solution? It's you have to get enough PJ memory to handle your workload, and you'll know if there's a problem because of your wait time analysis. Because of your wait time analysis. I call that an Oracle. Okay. time-based analysis. If you go to my website, okay, time-based analysis. Okay, if you go to my website, I'm going to close it. Hey, Melanie, I'm still okay, right? I think you're probably listening now. If I'm good, okay, thanks. All right. If you go to my website and you go to the webinars here, okay, I post both the member-only webinars, right? Like I'm doing one on Thursday about parsing. That's just for my members. I will post those, but there will also be public ones here as well. Okay, so look for ones that are about a time-based analysis, right? And that's what I mean. How do I know whether my PGA needs to be bigger? Well, in Oracle, Oracle will tell us by doing a time-based analysis. We will see these weight events right here. Okay. Now, there's multiple solutions, right? A bigger PGA is very Oracle focused. From an application perspective, I want to find a SQL that's sucking up all the memory, and do I really need to do all those crazy sorts? Stuff like that, right? So that's going to be an Oracle focused solution. Now, how do I find out what the SQL statements are? I would look at SQL statements in Ash. It'd be really easy to do this in Ash. Like, give me all the SQL IDs that were waiting, and when they were waiting, this was the wait event. You will find the SQL that's suffering from this. Okay, all right. Let me move on here. Oh, you're welcome, Sandy. Appreciate it. How about Windows? How about Windows? I don't know. It's gonna. Let me back. I don't mean to be too whatever the word is there, disrespectful about Windows. It's also gonna have the whole concept of real and virtual memory. You just got to figure out what the stats are. Okay, and I think if you look at what the task manager, that's going to give you page faults and some free memory, things like that. So, yeah, when I stopped the load, it still fluctuated. Yeah, the OS is probably still shuddering and shaking because it was an unnatural workload that I placed on it. Have you had a situation where even vmstat command freezes? Yeah, vmstat. That's what I was talking about. I was kind of hoping that would happen where all my monitors would just stop for a few seconds and then resume. That's what can happen when you have a really crazy memory problem. Okay, even the monitors just freeze up, which are usually really, really lightweight. Okay, yeah, 0 is good. 0 is good, 1's bad. I love stats like that. Yeah. Okay, OEM alerts work fine. Good, yeah, I'm sure you could use an OEM for this kind of stuff too. Okay, let's see, comment, keep up the good work, Craig. Awesome. Okay, I got it, Craig, keep up the good work. My company never spends money on anything. So he bought a team membership from OraPub because of your webinars. Thank you so much. Really appreciate that, David. Big time appreciate it. Let's see, Walker, that is a new team member, Walker. Great, great, great. SAR-W, is that it? Dang, I should have known that. W for swapping, right? I should have checked my book because I bet you the SAR-W is in there. Okay, page scans non-zero. Yeah, okay, let's see. Okay, this is a good one. What's the difference between this on top? That's your resonant set size. That's the real memory. That's memory that this process actually is like currently consuming in real memory. The shared, that's both the private and the shared memory. Okay, see the resonant set size, it's real memory and it's private, right? And so if you have a lot of processes that have a lot of non-shared private real memory, that can quickly consume a lot of memory at the OS. The shared memory, the problem is that if you add up all the memory here, you're going to have more memory allocated that's on the box. And you're like, well, that doesn't make any sense. That's because these processes are sharing memory. And the SGA can be part of this shared memory. So that's why you only want to look at the resonant set size. Okay. Yeah. Okay. There was a comment about Windows. Okay. Why would top have swap used but vmstat? Because there could be some. Oh, okay. So the question is, why would top have swap used as 0 but vmstat have a non-zero number. The only way, now remember, I'm not an OS person here, right? But remember, we do not have read consistency, and there could be timing, because we're only sampling, right, every like 5 seconds with top and every couple seconds here. So, I mean, we can get into these, dirty read kind of things. Sometimes I'll look at it like that. But if you see that consistently, though, they're like out of alignment. I don't know how that could. I don't understand that. Yeah, because they're both taking information from /proc though. So, okay, let's see. We still have like 100 people online here. Man, that's incredible. All right. Hey, to answer the question, and then we're done. What are some ways? Okay, what are some ways we can figure out if we have too much memory pressure? And then we're going to be done with it. Come on, just list these off. There's a number of ways. Go ahead and type those in. All right, I appreciate it, Kevin. All right, type those in, guys. Come on, you guys know this. This is the review. There we go. Okay, we got SAR. We had, what was the dash? Oh, pages swapped out per second. That's what I wanted to look at. SAR-W. Okay, for me, that's a big one. We could have done the dash B would have been good. That's what I actually used. vmstat, focus on the SO column. Must be 0. That's the big one right there. Okay. Let's see. vmstat, SAR. We got top, and we're looking at the resonant. That's how we get the big process consumers. Okay. Oh, I'm still sucking up memory right here. You see, the OS is saying memory is exhausted. That's why we're seeing swap out numbers right here. Okay. Okay, here we go. vmstat, that's right. Non-zero. Oh, yeah. Oh, that's right. The IO subsystem. Subsystem. Don't forget about that. We're gonna have some activity there. Kill-9. Yeah, that's how you fix it, right? Here we go. Oh, we got some tricky ones here. Yeah, vmstat, paint-scat. Yeah. Oh, and the other one on vmstat. In fact, if I wanted to do it like this. Okay, starts to decrease, and there is a threshold. Okay, when the bad stuff happens, and if you don't know what that is because you haven't hit it yet, talk to your OS admin and ask them what do they think a good threshold is, when you should be concerned, that kind of thing. That's what I would do on that one. Okay, so you can see there are a number of ways to monitor memory at the operating system. Okay, my favorite, you probably guessed, is the vmstat with the SO, but this is what I was looking for, was the swap outs per second right here. Okay, that's what I was looking for. Okay, that's the closest thing to the SAR. That's the closest thing to the vmstat SO column. Okay. All right, guys, that's it. Oh, okay. Somebody else had a question here. What option did you use for iostat? Oh, for iostat, I used it was XT. That's what I actually used here. Yes, I don't know if you could see that. Yeah, XT I used right there. But, and it's going to be different on different flavors of Linux too, or in Unix probably, I'm sure, on that. Okay, any other questions? We're gonna finish it up. We're gonna get this thing online here. So I get my virtual classes online here too. They're all ready to post so people can register. Very excited about that. I love teaching like this. Okay, guys, so that's going to be it for today. Again, hey, thank you all for joining me. I'm glad we had a bunch of people. I get pretty enthusiastic about that myself. So if you have any other questions, feel free to email me. Okay, we can do that. I'll get this online. Tell your friends about OraPub in the webinar because it will be out there for them as well. Okay, so all the best in your Oracle performance tuning endeavors. Bye for now, and thanks for listening.